let us see the concept of doubly linked list. First, let us start with the definition of doubly linked list. We can define a doubly linked list as a linked linear data structure which is having list of nodes, wherein every node can have one or more data fields, but only two link fields it is defined with, and the link fields are named as left and right. So it is that linked linear data structure. With list of nodes, and every node may have one or more data fields, and with only two link fields. Left link and right link. Okay. So let's have the representation for a particular node in a doubly linked list. If you consider that there is only one data field and obviously there will be two link fields. So we can have this as our data field, and we have left link defined and right link defined. This is the structure for one node in a doubly linked list. Like this, if you consider an example of doubly linked list with three nodes, this is the node for A, this is the node for B, this is the node for C, whose right pointer is null. Here if you observe this particular B node, B's left link is pointing to A. This left indicates that this particular B node's left pointer is having address of A, and B's right pointer is having the address of C. So with this, if you are at the B node, you can able to access to the previous node through this left link of B, and you can able to access the next node of B through this right link. So now with this, with the concept of doubly linked list, we are permitted to access the list or traverse the list in both the directions. Forward direction we can access it, and even in the backward direction we can access it while you are processing the list. So this is the flexibility or advantage we get with doubly linked list. And let us see the operations with doubly linked list. So we will find the two operations: inserting a new node and deleting a node. But before that, let's define the structure for a node. It can be defining a structure, struct node, and how many data fields we have taken one data field. So it is in data, assume that it is integer data. But coming to the link fields, we have two link fields, left and right, and both of them, they should be of struct node type. So it is struct node star left pointer and struct node and node type of right pointer. Let us take let us declare some nodes of this particular type. Can be some n1, n2 like this. Now n1 is of this particular structure it is following, and n2 also it follows this particular structure wherein this is data, this is left pointer and this is right pointer. So that is the structure defined. Now coming to your insert operation. Now there are, and we have our start pointer, assume that there are already two nodes in the list and this B is right as null. Here you want to add a new node with the data item C to this particular list. Let us consider the case if you want to add this new node to the end of the list. This end we have our B node. For this B node we have to connect this new node C. Actually here the difference we find is that earlier when you are trying with single linked list, when you are trying to insert a new node, you have to update only one pointer, that is your link pointer. But now it is that two pointers you have to update, your left pointer and right pointer. So here for this, the usual case, start pointer, if it is null, there are no elements in the list. If there are no elements already existing, you have to make your start pointer referring to that new node, and that new nodes left is null and new nodes right is also null. So this pointer will be null and this pointer will be null. It is referred with new. Else case, already there is one node. Assume this particular case, already there are some nodes and we want to insert this particular node to the end of the list. For that, as we know already the earlier procedure, it is to traverse the list from the begin to the end. It is that you have to take your address of the start pointer into temp and you have to pass through it while this temp link, temp right, this temp right is not equal to null. This last node's temp right, this is node's right part. Initially this is our temp and we have to check this right pointer is null. No, this right pointer is referring the address of this particular node, and this node, if you see at the right pointer, it is null. Like that you have to traverse and check. So temp right is not equal to null. You have to make temp equal to temp right. Like this you have to traverse. Once you reach this particular node, you have to make, this is your temp now. For your temp, temp's right should be assigned with your new. So this is linked with this, and your news left should store the address of temp. Here two pointers should be defined. One is from temp to new and another pointer is that from new to temp. Both left and right pointers we have to define. We have defined it. So through this you can able to insert a new node into the doubly linked list. But one thing you have to observe here is that right and left pointers both you have to define. And coming to the delete operation, Now to delete this particular node, actually we could find the advantage with doubly linked list in performing the deletion operation. That is, the node to be deleted is this. If this is identified as temp, in the earlier situations with single linked list and circular linked list is that previous node for that node also we need to have so that we can update the pointers. But with doubly linked list, that is not required. The node to be deleted, if you can if you can refer that with a pointer, deletion is possible. Now this is the node where we want to delete. So what we have to do is that we have to traverse the list from the start to the particular node which we want to delete it. So for traversing, it's our usual case. First we'll check list is empty or not. If it is empty, there is no possibility to delete a node, so it is under flow. Else we have to traverse till this particular node. For traversing, so we can take a temporary node and we'll initialize with start, and we have to know the data of this node to be deleted. So it is while this temp's data is not equal to this B. We have to traverse. For traversing, it is that temp equal to temp's right. Temp equal to temp's right. Once we could traverse and we have identified this temp node, now we have to write the statements for deletion. So here, once you delete this particular node, how the pointers to be rearranged is that this previous node to temp, this right should link to this right node's left pointer. It is that address of this node we have to put into the right pointer of this temp's left. This node can be referred with temp's left and this node is referred with temp's right. Now temp's right address we have to store to temp's left address location. So for that, it is temp, its left is referring this particular node, and this node's right address location can be referred with this. This right address location should have the address of temp's right. It is temp's right. So this node's address. Then it is the other pointer. These two pointers. It is temp's right. Temp's right. This particular node's left pointer now should be referred to temp's left node. So it is temp's right, right's left should be updated with temp's left pointer. I think you understand this. Once this temp node is deleted, we have to update temp's left node should have the address of this temp's right. That should happen. Vice versa, this temp's right left pointer should have the address of temp's left node address. For that, it is temp left, it's right. This is temp temp left refers to this particular node. This node's right pointer. Right pointer should hold the address of this particular node. This node is referred with temp right. So it is temp right. Then temp right. Temp right is referring this node. Temp's right's left pointer. This pointer should have the address of this particular node, which is referred with temp left. So it is temp right left is equal to temp left. So with these two statements, we could remove the connections between like temp and the previous node and the next node. Now simply we can do that as temp left is null, made null, and temp's right is made null. Now we can free temp. With this code, we can delete this particular node from the doubly linked list without having identified the previous node to the temp node. This is another advantage we have with doubly linked list. Thank you.